Green hydrogen. Sounds perfect. No carbon, just water vapor. But here is the problem nobody talks about.
Producing hydrogen takes massive electricity, about 52 kilowatt hours per kilogram.
And in Malaysia, renewable electricity is limited. The power sector needs it first.
Our industries run non-stop, but solar only when the sun shines.
So, green hydrogen gets pushed aside. Too expensive, too unreliable.
Sometimes there's too much renewable power, and the grid can't take it. That energy gets wasted.
Other times, not enough, no consistency.
So, most hydrogen projects just wait, or they use fossil fuel electricity. That defeats the purpose. And that's where our idea begins.
We ask a different question.
What if hydrogen isn't produced constantly?
What if it is produced only when it makes sense?
Introducing deferred energy. Produce hydrogens only when renewable energy is surplus or electricity is cheap. Store it. Then use it when energy is scarce or expensive.
Hydrogen becomes a time-shifted battery, but better because hydrogen stores energy for days or weeks, not just hours.
During peak demand, the electrolyzer shuts off. No competition with homes and factories.
During surplus or off-peak, it runs at full capacity.
This also saves money. Off-peak electricity is cheaper. Surplus renewable is sometimes even free.
Lower cost equals to viable green hydrogen.
That's the innovation, not a new machine, a new way to think about energy and timing.
But hydrogen needs more than electricity. It needs clean water.
In Malaysia, industries already treat the wastewater before discharge.
And we add one small polishing step that turns treated wastewater into electrolysis-grade feed water.
No competition with drinking water, no new water source needed.
Next, waste heat. Most industries release heat into the atmosphere. That's free energy floating away.
We use simple heat exchangers to capture that heat.
Important, heat doesn't power the electrolyzer. That would need complex cycles. Instead, heat supports the system by preheating water and maintaining temperatures.
Simple, cost-effective, and reliable.
So, what does this achieve? Normally, hydrogen production requires about 52 kilowatt hours per kilogram.
With our integrated approach, deferred timing, treated wastewater, heat recovery, we reduce that by 10 to 12%.
That doesn't sound huge, but at industrial scale, with tons of hydrogen per day, the savings are massive.
Lower energy input means lower cost. Lower cost means viable business case.
And because we use off-peak and surplus power, we are not stressing the grid.
This is how green hydrogen becomes practical, not just aspirational.
Now, where does the hydrogen go? Not into fuel cells or new engines. That's expensive.
Instead, we blend it with fossil fuel in existing boilers.
Most industrial boilers can handle up to 10 to 20% hydrogens without modifications.
That means immediate emission reduction without huge capital investment.
And this is our vision for Malaysia's energy transition.
Practical, scalable, grid-friendly.
Our energy,
our responsibility.